Hello, we are going to work on figuring out some trig values when we're given a line. So we want to find the 6 trig values of angle theta when the terminal side, remember terminal just means ending, is defined by this line. And then it also gives us this restriction of when x is greater than or equal to 0. Okay, this looks like a very terrifying problem, but it's not bad at all. So let's go ahead and draw our line first. So let's make this into y equals mx plus b. So we're going to subtract x from both sides. Going back to algebra 1. So we get y is equal to negative x over half, or over 2. So we could just say negative 1/2 x. Okay, so let's graph this line. So there is no b-intercept, which means our b-intercept is going to be 0. And then our slope is down 1 over 2. It doesn't have to be exact on the units, okay? So we're going to go down. I'm just going to go down 2 units. We're going to just call that 1 and over 2. But again, this does not have to be exact, you guys. We could care less about the actual units. Okay, so here's our line. Great. Now it says when x is, remember this is bigger than 0. So we're talking about this triangle over here, okay? So we don't care about this side at all. We want to find the 6 trig values, and this would be our angle theta. Why did I draw it like this and not off the x, or I'm sorry, the y-axis? Is because, again, it needs to be one of our bow tie triangles, okay? So we're going to be working with this guy right here. We know what this length is, right? Because we would have gone with our slope of up 1 over 2, right? Is going to be the opposite. So we would have had this one be a positive 1 and this one have been a positive 2. Okay, so now we have 2 side lengths of our triangle. How can we figure out what the third one is? Well, it's a right triangle, right? So we can do Pythagorean theorem. So we have 1 squared plus 2 squared equals, we don't know squared, that's going to be our hypotenuse squared. So 1 and 4, so we're going to get 5. So x is equal to square root of 5. So this guy is now the square root of 5. Okay? All right, all the hard part is done. Now we need to figure out what the sine, the cosine, the tangent is, and then also the opposite, so the reciprocal, which is cosecant, secant, and cotangent, okay, of this lovely angle. All right, so sine, remember our lovely SOHCAHTOA. So we're going to go sine is, this is our opposite. Make that a little bit bigger for us. This is our adjacent, and then our hypotenuse of square root of 5. So sine is opposite over hypotenuse, so opposite over hypotenuse is going to be 1 square root of 5. Oops, that's a 2, not a 5. But we can't have a root in the denominator, so we have to rationalize it. So we get square root 5 over square root of 25, which is just 5. Okay, so that's our sine. Then we can do the reciprocal identity of cosecant, but remember we can reciprocate this, but if we reciprocate this, our radical is going to go into the denominator. We can't have that, and then we'd have to rationalize it again. But if we go to our original function, which was this guy, and we reciprocate this guy, we would get the square root of 5 over 1, which is allowed. We don't have to rationalize that at all. So we're going to leave that. So when you rationalize, it's easiest to go back to the original function before we rationalize to reciprocate it, okay? That will help us get our ratio faster. All right, now we have cosine. That's AH, so 2 over square root of 5. Well, we can't have a radical in the denominator again. So multiply, multiply. So we get 2 radical 5. Root 5 times root 5 is 5. So 2 square roots of 5 over 5. And we go back to our original AH, and we can reciprocate that. So we get radical 5 over 2. And then last but not least, we got tangent So we get a half. And then the reciprocal of a half is 2. Okay. And there are our answers. The thing we need to watch out on these is if our ratio was somewhere else in a different quadrant where all of the side lengths aren't positive. So let's say we did another triangle. We had a line and let's say it went this direction. And we still had the restriction of x is greater than or equal to 0. So we would be in this quadrant down here, right? So this would be a positive A value, but this would be a negative O value. So it's important that when you're looking at your triangle off of these lines, that you look at the sign of those sides as well. So is it a negative value or a positive value? So make sure you watch out for that. Okay, that was the hard one. Let's look at these easier ones here. So this one says find cosine if secant is 5/3. So this one is like painfully easy because cosine and secant are reciprocals of each other, right? This is a reciprocal identity of this. So cosine theta is just the reciprocal of this, 3 over 5, and you're done. We could make this a lot harder by saying, okay, well, this is AH, so then this one's going to be HA. There's H, there's A. And then if we didn't know what that, let's say we had to find tangent. Let's say it asked us to find tangent. In that case, we would be opposite over adjacent, right? Well, based on this triangle, doesn't matter where we draw the triangle. If this is our theta, our adjacent is 3, our hypotenuse is 5. Let's say we don't know what the opposite is. Can we figure it out? Well, we sure can because it's a right triangle. And then that's a Pythagorean triple triangle, which would be nice to know because if we didn't know it, we could do Pythagorean theorem. But this is a 3, 4, 5 triangle. And if you're not sure or don't believe me, do Pythagorean theorem and you'll get 4. So then we have our O, right? So here's our adjacent side, here's our O side, here's our hypotenuse. So now we can say, okay, tan is O, 4/3. Easy peasy. Okay, so if it doesn't give us find the reciprocal of the identity that was given to us, we can figure it out with just a teeny bit of math. All right, let's look at this one. So we want to find sine if we know cosecant theta is this. Well, again, sine and cosecant, those are reciprocals. So we can just take the cosecant and reciprocate it. Well, we can't have a radical on the bottom. So, couple of things. I look at this and see radical 12, and that's not reduced. We can pull a number out of that. If you don't see that, that's fine. We can go straight to this. So then we would get -2 times radical 12. Radical 12 times radical 12 is just 12, right? And then remember when we are reducing these guys, we can reduce it because there's no plus or minus in between those two terms. It's not a binomial. If it had a plus or minus in between those two terms, we can't cancel part of them out. We'd have to cancel something out of all 3 terms. So -2 and 12, that's a -1/6. Well, I still have the square root of 12, which is not reduced. So remember back in the day, we can do, okay, what goes into 12? 2 and 6. 2 and 3 pairs go out, so it's really 2 square roots of 3. Or another way, this is one option to do it. Another way that is common to do it is think of perfect squares that go into 12. 4, we write the perfect square first. Left over is 3. Square root of 4 is 2. 2 square roots of 3. So either way, you get the same answer. So it doesn't matter how you do it. Just, we got to simplify it. Okay. So square root of 12, we said, is really 2 root 3. So I can rewrite this guy. There's a negative in front. So this guy is really going to be -2 square roots of 3 over my denominator is 6. Okay. And we can reduce this again. So I have 2 and 6. So that reduces down to 1/3. Keep the negative. So really this is negative root 3 over 3 is how you guys would write your answer. It's not wrong to have the 1 in there. It's not necessary. So make sure you guys are reading the directions carefully on how to enter your answers into Canvas. So that would be the answer for that guy. If you wanted to have reduced this in the very, very beginning, let's look at how to do that quick. I'm trying to find a piece of paper to write on quick. Ooh. This will do. Okay, so if you saw, let's say we started out all the way up here and saw that the radical of 12 can be reduced. So let's go ahead and reduce it. You can do the tree or pull out perfect squares, whatever you prefer. So then I would have gotten negative 2, the reduced square root of 12 is 2 radical 3. Okay. 2's cancel. I can do that because it's not a binomial. I'm not adding or subtracting these two terms together. It's one term in the denominator, one term in the numerator. Granted, it's a nasty term, but it's one term. So we have negative canceled out. So that's negative. And then when something cancels out, we hold it with a 1. And then radical 3. And then we can multiply top and bottom by square root of 3, square root of 3. So we get negative square root of 3. Root 3 times root 3 is root 9, which reduces down to 3. So it doesn't matter which way you guys see this. It's just a matter of the end result. So I don't care how you get there. Do you reduce it first? Do you not? Do you reduce it midway a couple of times? Do you do a factor tree? Do you pull out perfect squares? That's the nice thing about math, is it doesn't really matter how your brain works. You just have to use these rules and steps to get to the end result. All right, that's it for that.